So chapter 1. Chapter 1 always ends up being a little bit of an introduction. Can you guys see that okay on the screen? But we got to start somewhere. So Soda Pop Fizz. This cracks me up because does anybody call it Soda Pop? Doesn't that sound like from the 50s or something? I'm not sure exactly what they were doing, but I grew up in Minnesota and Iowa where we called it pop. And then I moved to Indiana and I lived in North Carolina and now I live in California where it's called soda. And in the deep south they'll call it Coke or Pepsi. They like an orange Coke, and they don't mean Coke with orange syrup in it, they mean orange soda. Very interesting. So I don't know if the author's, trying to just cover all the bases or what, but I'm just going to call it soda because I've said soda too long and now pop sounds silly. So let's think of soda. So a can of soda is a liquid, but it's got all that fizziness in it. Okay. And soda is composed of tiny particles called atoms. And these guys, when we say they're very small, they are mind-bogglingly small. A single drop of soda has about 1 billion trillion atoms in it. One drop, 1 billion trillion atoms. That's just crazy. We can't even comprehend that. And these atoms are, what we're going to be looking at in chemistry, what we're going to be studying. Molecules are groups of atoms that are held together by a chemical bond. And all of matter is composed of atoms and molecules. So your body is composed of atoms and molecules. The air that we're breathing, the chair that you're sitting on, the paper that you're writing on. Here's an example, an illustration of a water molecule. It's a molecule. That means it's more than one atom and they're bonded together. You can think of them as being glued together. So this looks like 3 balls that are glued together. There's an oxygen atom in the middle, and there's 1 hydrogen atom over here and 1 hydrogen atom over there. And we're going to learn a lot more about these sorts of things. We've got to start somewhere. So in soda, we have different kinds of molecules. There are carbon dioxide molecules and water molecules, and then there are other molecules that cause it to have that particular color and flavor. So here's a can of red soda, pouring it into a glass. This is an illustration of a carbon dioxide molecule. That's the gas that's in those fizzy bubbles. And here's a water molecule. And of course, soda is mostly water with other stuff put into it. And here's a different illustration showing you all these, how the carbon dioxide and the water molecules, they're all mixed together. So here, again, we're just kind of looking at carbon dioxide and water. So here's carbon dioxide, which is 3 balls. And water, which is 3 balls, 3 atoms. But the water is more of a bent shape. In the carbon dioxide, those balls are connected in a straight line. There's a reason for that. And all carbon dioxide molecules are going to look the same as each other. And all water molecules are going to look the same. You're not going to see a water molecule that's straight like a carbon dioxide molecule. And we're going to learn why they are like that. So, in the can of soda, when you open a can, you hear that psh sound, right? That's because in that little airspace above is a pressurized carbon dioxide gas. Under pressure, carbon dioxide, which is a gas, there's a lot of carbon dioxide in the air in this room, because when we breathe out, we exhale carbon dioxide. It's a gas at room temperature. So it doesn't really want to be dissolved in water, but you can force it to dissolve in water by putting a lot of pressure over it. So as long as there's that pressure held in that can, then the carbon dioxide stays in the water and the soda stays fizzy. If you open the can and release the pressure and let that can just sit there for, I don't know, let it sit there for 3 days. Is that soda going to be as fizzy as a freshly opened one? Nope. When we open that can, the pressure is released and the carbon dioxide starts coming out of the solution. And that's why you see the bubbles. You can see this in a clear 2-liter bottle. When you open the lid, all of a sudden you see bubbles starting to come up. That's the carbon dioxide coming out.